Hey everyone, welcome back to 197 Concepts. So, in this video, I'm going to discuss with you uh, how you're going to compare the two strings using the DOSBox and telling if the two strings are equal or not. So, you might be able to see the program that I need to compare the two strings in front of me. Okay, so yeah, let's start into the explanation. The very first line is as a common line, assume CS colon code, comma DS colon data. So this tells our data segment and this defines our code segment. Okay. Now what I am defining in the data segment are nothing but two different words with S1 comma S2, and yes, I am keeping both as same for easy comparison. Okay, then I'm also defining two variables called as eq comma ne. So eq is for equal, like if s1 and s2 are same, then I will be displaying this eq, and if s1 or s2 are not equal, then I'm going to be displaying this ne. Okay, so these are just the variables. Eq will be holding equals character, equals string, and ne will be holding not equal string. Okay, be mindful, every string here has to end with the symbol dollar because it tells the end of that particular string. If you don't keep that, so it can continue s1, whatever you have saved in s2 will be continued as s1 itself. There will be no s2 variable or s2 string. Okay, so that's why you have to end everything with a dollar symbol. Now I'm ending the data and now I'm going for the code segment. Okay. So yes, we initially know that all the data has to be go into the data segment, and this cannot go directly. This has to go through AX from the data, right? From the memory location. Somewhere my data is stored in the memory. It has to go into the AX and then it has to go to the this data segment. That are these two lines. Also, what I'm going to do is I'm also moving the same data into the extra segment also. Okay, that is extra segment. I'm moving the same data into the extra segment also in order to compare the DS and ES. Now, what I am doing is I have S1 and S2. So S1 will be stored, the effective address of S1 will be stored in source index, whereas the effective address of S2 will be stored in DI. Okay. Now, what is LEA? LEA is load effective address. So what it does is, if I have SI, not SI, if I have S1, in S1, what I have EQ, not the EQUL. So yeah, not this. So in SI, not again SI. Okay, so in S1, what I have is Madam, MADAM. Okay, so this is stored as 10, this is stored as 30, this is stored as 50, somewhere it's stored. When I execute this command, what the program is going to do is, what the process is going to do is, it's going to store this value 10 into the source index. Okay, the same way when I'm executing this LEA with the LEA with the DI comma S2, so the first character address will be stored into the data segment. Now simply what I'm going to do is I'm comparing S1 and DI. So for that, what I will be doing is I will be keeping so square brackets. So what it does means, SI is holding a data number 10 and DI is holding a value say 20. So 10. So 10 is now an address because of the square brackets. It will go at the 10th location and fetch the variable M or the character M. So that's why that's the thing DI is going to do if there are brackets. Okay. So here I've selected a different approach. Okay, now what I'm doing, I have selected this one, I've completed this one. So I'm loading the effective address of S1 into SI, and S2's effective address will be loaded in DI. Now for the number of times. See, I already know the variable. That's why I'm having 1, 2, 3, 4, 5. I need to run, I need to do the comparison 5 times, right? So for that purpose, I'm keeping a count of 5 into the CX register. And finally, what I'm going to do is this is clear flag. Clear flag. What is the purpose of this is, yeah, clear flag, that to the directional flag. Okay, so CLD. So CL means clear and D means directional flag. Clear the directional flag. What it does means, since the directional flag is at 0, it will tell the processor to move towards the right side. If it is at 1 or some other value, if it is at once, because what we say, flag registers have only 0 and 1. If you are having 0 value in directional flag, it is going to move from left to right. Okay. If it is at logic 1, then it's going to be in the opposite direction. So right to left. Okay, so all my characters will be stored from left to right itself, right? My characters are stored as MADAM. It's not stored like this MADAM. It's not in the opposite manner. It's not stored in this way. It's stored in this way. For that purpose, I have to tell the processor to move from left to right. And for that, I'm just clearing out the directional flag. And finally, what I'm doing is I am comparing CMP, means compare every byte, single byte, right? Of what? Of these characters S1 and S2, of these strings S1 and S2. So I'm comparing the single bytes. Okay. So not the whole string at once. First, what I'm doing is I'm taking M and M from here. Then I'm comparing these two. Okay, I'm comparing these two. Definitely, what I will get, since I'm doing a comparison, I will get the result as 0. If I get this one, then that means both the characters are not equal. Since they are equal, definitely I will get a logic 0, where in the 0 flag, not in the 0 flag, I will get a result as 0. I will get the result as 0. Since the result is 0, the 0 flag will stay at logic 1. Okay, we'll stay at logic 1. So that is what this is, repeat. Okay, so repeat. This tells the processor to repeat the same function again and again until your count, either your CX becomes 0 or you get the 0 flag as 0. That means your result is not 0. Okay, so if the 0 flag is 1 or your count is not 0, okay, that means greater than 0, then the comparison goes on. Okay, there is no stop, there is no end for that. After, if any of these conditions, either the count is 0 or the 0 flag equals to 0, that means you are getting a result as 1. Then it is going to come out of this and it is going to execute this uh, step. Okay, so JZ same. What is going to do is it is going to jump at this label. It is going to jump at this label when you have the 0 flag, when the 0 flag is equals to 1. Okay, then yeah, when the 0 flag is equals to 1, that means your result is 0. Result is 0. That's why you are jumping into the same. And what you're saying, you're just going to display it with the help of int 21h, and you're loading AH. For displaying the string, you need the interrupt 21h, and under interrupt 21h, you need the 09 value to display a string. Okay. And here, what you are doing is load effective address of TX into EQ. Okay. So that's what we are doing here, and finally we are ending the program. Now, if the result after comparison of two characters, you get the result as 1, what it is going to do is it is skipping this line. It's going to skip this particular line and the program is going to jump from here to this label. Okay, so yeah, it will go in a stepwise manner, and this will, since the condition is not fitting here, this again will jump to this label. So not same, and it is going to execute. It is going to say it is going to load dx with not equal variable, ne variable. That means this this variables, this uh, string. And finally, by using int 09h and 21h, we are going to print it on the screen. Okay. Hope you have understood the program. Now let us try to execute this. And for that, first I have to open the DOSBox. Yeah, I'm going for the full screen. So these are the basic steps. Now what I'm going to do is I'm going in the edit and I'm pasting my program. Oh, I've not copied the program. There's a notepad. Yeah, there it is. So right, it has typed the program, it has copied the program. Now I'm going to just save it like EQNQ. Okay, equal not equal dot asm. Now I just need to exit from here. MASM EQNQ dot asm. So two severe warnings, reserved word EQ and NE. So by default, the system has reserved those two words. I need to edit it. Okay, EQNQ dot ASM. So this one EQ. What I'm going to type is EQU, EQU and NEQ. Okay, so let us keep this 4. So that will be much better. And the other thing is I have to change here NEQU. And the other thing is, yeah, I have to change here EQU. So Alt save exit. Now MASM EQNQ dot ASM reserved word. EQ is also reserved word. So I have to change it again. So NEQ is okay. Uh, what I am going to do is I'm going to keep it with double E. So system has already defined these words and it is in the data of the processor. So I cannot change those. So those are saved as commands. It's better to go with other name. Now MASM EQNQ.asm, no errors. Now linking and EQNQ.obj. Finally AF debug EQNQ.exe. So yeah, if you execute here, so 1831 loaded in AX and you have got your characters at the bottom of the screen, bottom right of the screen, and you won't be able to see the output here, right? You won't be able to see the output nowhere. Okay, so this is just the error debugging. So logical debugging will be done here. If you really want to see the output, you have to come to this screen and type your file name eqnq.exe. It's going to tell that you have to execute the file, you have to run the file, and if you enter, you get the output as equal because the data that we have given is madam and madam. So both are same. That's why we are getting the value as equal. If I am going to change the value, so yeah, that's a little bit problem. So again, open DOSBox. Since I've already saved the file, simply I can run the MASM EQNQ. Oh no, I have to edit it, right? Yeah, I need to mount C, edit EQNQ.asm. Now what I'm going to do is I'm going to simply remove one character, or I'm going to change madam with MA, magma and madam. Okay. Now what I'm going to do is I'm going to save it, and now I'm going to MASM EQNQ.asm, so no errors. Link EQNQ.obj, and finally, I'm not going for the debugging screen. I'm just running the file. So EQNQ.exe, not equal, right? So I've got the value not equal because I have not placed the names equally. I have placed magma and madam. So comparing those two, you won't get a correct output. You won't get an equal output. And if you go for the debugging screen, like again, I have to stop this. Just stop this, and so yeah, here MASM EQNQ.asm. I'm not changing the files. Okay, link EQNQ.obj, and if you go for the debugging screen, EQNQ.exe, observe the zero flag. It is zero. That means presently I'm getting the output as some logic 1. Okay, so now I have moved the data. See at the bottom of the screen, now I have loaded the data. What I'm going to do is I'm going to move the extra segment. I'm going to load the extra segment with the same data. Now SI is loaded, DI is loaded, and CX is also loaded with 05. Now I'm going to clear the directional flag. So directional flag initially is 0. So there will be no changes here. That's it. Now I'm going to compare single byte. Okay. I'm going to compare the every byte of both the characters. Observe the 0 flag here. That means now I've got the 0 flag as logic 1. That means my result, the comparison result is 0. There is no other logic other than 0. So that's why my 0 flag is 1. And this next condition is met. So this next condition is met. That's why I am going to jump towards the label 001E. And if you have observed it, my CX count is 1. Because at the same time, what I'm going to do is I'm going to repeat it. So 0 flag is 0. That's why I'm not coming out of that loop. I'm just going to execute it again and again. When my 0 flag became 0, now I have jumped to this variable. That's because I have met the dollar, or I have completed the execution, or my count is complete. So these three are the only conditions. Okay, so that's why if you click here, it will go for DE, load effective address. The address DX with is 0012. So 0012, if you search here, there is no such thing here, because you are going to load it with not equal value. You're going to load it with not equal value. Now that not equal value, the first character is stored at, the n character is stored at 0012, and now it's going to just display that. That's it. Okay. So this is the whole execution. Hope you have understood this. Yeah, one more thing. See, my count is still at logic 1. There is still one more loop. There is still one more loop. That loop has not been executed because in the middle, after the counting of three characters, that is MAD, in the second string, the fourth character is A, whereas the fourth character in the first string is M. So there I have got a mismatch. That's why my zero flag has gone to 0 and the comparison result is 1. So comparison result 1 means they are not the same. That's why the count is stopped at after completing 4 cycles, the count has been stopped. There is no execution of the loop another time. Okay, but if I go back to the editing screen, Okay, and I change this back to equal. Okay, if I change this back to equal, and again MASM EQNQ.asm link EQNQ.obj, and finally AF debug EQNQ.exe. Now, when I execute, okay, keep an eye on zero flag. It's going to stay at logic 1. Okay, so yeah, I have executed it. I did it a little bit quickly. The count, the CX register is at all zeros, and the zero flag is still at logic 1. That means my comparison result is 0. My comparison result is 0. That's why the zero flag is still at 0, and I have executed the complete program. Okay, so that's the difference I wanted to show you. Hope you have understood this program, and that's it in this video. See you in the next one. Thank you.